Welcome to example number 2. A lifeguard ropes off a rectangular area using 600 meters of rope up against a beach. What is the maximum area she can enclose? Alright, so if you understand the purpose of the lifeguard roping off areas of the water, they want to make sure that people don't swim out too far. So the rope is kind of a boundary of where people should and shouldn't go. So right here, if I have this beach, this lifeguard is roping off a rectangular area right here. And so the rope only needs to be three-sided of this, because you don't need to rope off the beach itself. People are allowed to go and walk here. They just shouldn't be going this side for whatever reason. Okay, so that's the rope here. And we know that there's 600 meters of rope. So the rope is going to be something called the perimeter, mathematically, because we have 600 meters to go from here to here to here. I'm going to call this W, this the length, and this is the width. So we have 600 meters to cover two widths and a length. So really the perimeter is known as two widths and the length in this for this particular shape. And so we have one equation here. They're looking for the maximum area. So maximum area, when we're talking about maximum, you already kind of understand that this implies this is a vertex. They're looking for the vertex. And in order to find a vertex of something, we're going to have to find an equation that represents that, an equation that has a maximum. Right now, this is not an equation or relation that is a quadratic. There's no squared value. And they're talking about area. We're trying to maximize area. So I don't even have an equation for area yet. So I need to make an equation for area. So I'm going to call this equation A for now. And let's talk about the area of this shape here. So the area of this shape that's enclosed is length times width. This is still a rectangle. So area is equal to length times width. And that's a formula. And I'm going to call this equation B, because that's my second equation. And they're not asking us to maximize length. They're not asking us to maximize width. They're asking us to maximize area. So we need to keep this. We need to work with this equation. So I'm going to write A. But I need a relation here between A and something else. And that something else has to be a quadratic. Right now, this is not a quadratic at all. But what I can do is I can use this first equation, isolate for L or W, and substitute it into here. And then, hopefully, I will have one variable on this side of the equation, and hopefully it'll be a quadratic so that I can find a maximum, and I can find that vertex. So in this case, and I can choose to plug in isolate for W or L. But if I isolate for W here, there's already a coefficient here, which will cause a fraction. So it's better to isolate for L here, because there is no coefficient. And I need to get rid of plus 2w, sorry. To get rid of plus 2w, we're going to subtract both sides by 2w, so 600 minus 2w. And I can substitute this into here. So substitute. And so instead of L, I am going to replace it with 600 minus 2w, because that's what L equals. L equals 600 minus 2w. And there's still a times w here, which I'm going to write outside here. And so now I have a quadratic in factored form. Even though it kind of doesn't look like it, I can write something else here. I can do plus 0 if you want to put it brackets in. So this kind of looks more like in factored form, because I have two binomials equaling to, and they're multiplying each other, so that's considered factored form. So if they want to try to find the vertex, I can certainly expand this and change this to standard form, and then use either the quadratic formula or complete the square. So that's something we can do. So we have three options here. Option 1, where we will expand, which we'll put in standard form. And then once it's in standard form, you can complete square to change it to vertex form. And then when you get the vertex form, you can pick out the vertex from there and get the maximum area. And then you can get max area, like that. That's option 1. Option 2 is to expand. And instead of completing the square, you can, number 2, use the quadratic formula. And then average out the zeros, which are going to be the x-intercepts, and then plug in average x value into equation C. So I'm going to call this C here. Equation C. Plug into x average into equation C, and then you can find your max area from there. So that's one option. That's the second option. And the third option is we have it in factored form. Instead of using the quadratic formula to find the zeros, we can just use this to find the zeros right away. So that's one we're going to do because it's the easiest and it looks like the shortest steps possible. So step 3 is to set a equals to 0. So a equals 0. 600 minus 2w, and there's a w here, plus 0. And now that we have a binomial, two binomials multiplying becoming 0, we can now, only now, we can separate 600 minus 2w equals 0, and w plus 0 equals 0, which is going to be 0. In this case, we can now isolate for w. I'm going to move this to the other side, so it becomes plus 2w. And w equals 300. And so we have both the zeros here. And once we have the zeros, we're going to average them out. So average w is going to be 300 plus 0 divided by 2, which would be 150. So I know that the maximum occurs at 150. So I know that this is going to be 150. And this is also 150, and then you can use this formula to find out what L is going to be. So let's do that. So I'm going to box this up so it's easier to follow. So that's step 3. Then we averaged out the w-intercepts, and now what we're going to do is we are going to sub w in. So sub w equals 150 into a. And so we plug it in. 2 times w, which is going to be 150, plus L equals 600. So 2 times 150, which represents multiplying these two up here. There's going to be 2 150s, which is going to be 300. Plus L equals 600. So the total fencing, the total roping is 600. We're going to subtract 600 minus 300, which will be 300. So the length is going to be 300. So this is going to be 300 right here. Okay, and so now they want us to find the maximum area. So max area, we go back to this equation. So go back to equation B. Area is equal to 300, which is the length, times the width, which is 150. And that is going to be 45,000. I can count zeros. It's 45,000. And so now this is a word problem. We need to end off our question. Answer with a word, with words. So the maximum area is 45,000 meters squared. Okay, so I just want you to understand that there's many different pathways, and you should be able to do all three and understand, find that they're going to be all giving you the same answer, whether you're using quadratic formula, factoring, or completing the square. Okay, take care, and we'll see you in the next example.